Chapter 5, Exercise 5.75. Part A. Determine whether each molecule is polar or nonpolar. CH2F2, it's polar. It's because carbon forms 4 single bonds with 2 hydrogen atoms and 2 fluorine atoms. The electronegativity of carbon is 2.5, hydrogen 2.1, fluorine 4.0. The 2 fluorine atoms would like to attract the shared electrons toward themselves. That's reason 1. Reason number 2. Both CF bonds are polar with the positive end on carbon, negative end on fluorine. And also the fluorine carbon fluorine bond angle is not 180. It's not linear. Therefore, the 2 bond polarities from the 2 CF bonds, they do not cancel. We have a dipole here, a non-zero dipole with the positive end on carbon, negative end between the 2 fluorine atoms. This one is nonpolar because tellurium has 6 valence electrons, so this central atom forms 6 single bonds with 6 fluorine atoms. The molecular geometry is tetrahedral. Although the 6 bonds are polar bonds, the polarities cancel. SiF4 also nonpolar because this is a tetrahedral structure. In a perfect tetrahedral structure, the 4 bond polarities cancel completely. So that's why these 2 are nonpolar, even though this tellurium fluorine bond is polar. A single fluorine bond is polar, but overall the 2 molecules are nonpolar. So I'm gonna show you the mastering chemistry solution here. In this SiCl4, I think it's SiF4. Yeah, SiF4, but anyways, it's tetrahedral, and you can see it here, and the vector addition of the 4 equal in magnitude dipole vectors leads to 0. This is the mathematical language describing the cancellation of bond polarities. This TeF6, tellurium hexafluoride, it's octahedral, so the bond polarities cancel. Alright, so you have a bond pointing up, another pointing down, they cancel. One pointing to the left, one pointing to the right, they cancel. One pointing to the front, one pointing to the back, they also cancel. Alright, but in C2, in carbon H2F2, it's also tetrahedral, but the bond polarities do not cancel. Actually, you have positive end between the 2 hydrogen atoms, the negative end between the 2 fluorine atoms.